Well, hi everyone, and greetings from Northern Michigan. This is Bob the Science Guy, and welcome to our live stream tonight. We've got some special guests tonight. This is our panel. If you'd like to join the live stream, what you do is you just go ahead and click the link that is in the description, and you're going to go over here to the green room live. That's the waiting room for the live channel, and one of us will move you down here, and you'll be part of the YouTube discussion. Hi panel, how is everybody doing tonight? Hi panel, how is everybody doing tonight?
Still alive, scared the licking daylights out of me again.
Doing okay.
Still alive. A couple heart attacks later.
You guys ready to do some science?
Yes.
As long as doesn't start with pseudo.
Ready.
All right. I'm going to adjust my level here a little bit because you guys are a little quiet to me for some reason. Let's go see what we have here.
Doing great, Bob.
All right, let's see if everybody's blown that all out. Is that working okay?
Hi, Bob.
Yeah, you're looking fine there. I can't hear any of you for anything. I can just barely make you out. But here's what we're going to do tonight. I was thinking about changing out my chair today for a less squeaky one, and I forgot to do it, so you're going to have to deal with this. And I thought I'd bring the panel in today because I had a question that I wanted to ask, and that is, does science prove things or disprove things? Which is easier for science to do? Which is more valuable for science to do? To know something isn't something, or know definitively it is something? Because the reason that I ask this question is it's so difficult in science to get a definitive answer that yes, absolutely, this is the only way that this can work, and it's the end, we don't need to even look into it anymore. That's just not the way science works. So, however, I can use science and tell you something is not something. So, for example, if I want to look at a rose, a red rose, I can tell you spectrographically, visually, that it is not a blue rose. It's a red, it's not a red rose per se, but I can tell you definitely it's not blue. Because you just asked my wife, there's about 40 different shades of red, and everybody has a different name for it. But we all agree it's not blue. What do you guys think? Have you run into that in the flat earth at all?
Yep.
Do I even need to answer this?
All the time, seems anyway.
Seems like just a little bit ago.
Oh yeah. Yeah, I was watching you run into it.
Yeah, it's like running into a wall.
Yes, it is, Squeak.
See, that's it. It's harder to prove something. Yes, it is this than it is to say it's not this. You know, it's just so much easier. Or you can say an apple's an apple. Well, how do we know it's an apple? Well, it's not a banana. It's not a peach.
It's not a
cucumber.
it's not Adele.
Yeah, I mean, well, we know it's not blue. We know it's not, green. We know it's not purple. If you have
past date.
Variables.
Yeah.
It's impossible to eliminate every variable. So what you
Correct.
have to do is go through a process of
Elimination.
Well, yeah, that's kind of the way I look at it. It's a lot easier to rule out things than it is to rule them in. So here's the problem that we run into with the flat earth. What's the first question flat earthers always ask those of us that actually understand and deal with science in our daily lives? And that is, okay, well, what's your best proof that the earth is spherical? That's kind of a difficult question to answer because then they always just sit down and try and pick one little aspect of it apart or play a little definition game. or something or other like that. How about we just prove the Earth isn't flat? So what do we want to prove tonight? How about the Earth isn't flat
Sure.
and stationary? Can we do that?
Yes.
All right.
Apparently, by the flat Earth definition, no.
Well, let's go find out. So let's just limit our discussion to two things. Let's prove that the Earth is not flat and prove that the Earth is not stationary. So what is the best evidence, for example, that the Earth is not a stationary object?
The
I
sun.
have a gyro
Sunrise
compass.
and
I have a
sunsets.
gyro compass in my garage.
Okay, well, sunrise and sunset, can we acknowledge the fact that the celestial sphere over our head may be moving around us and the Earth could still be stationary?
Well,
I don't think so.
Wait. Spinning.
If that's the only thing you look at,
How do we change temperature?
Well,
The way that
Different
it's
seasons?
moving. The way that it's moving would not make sense for it to be rotating due to the way of its makeup.
well,
It'd make more sense for it to be static, relatively speaking.
well, that's true. It's much bigger than the Earth is. But let's just assume, for the sake of argument, for example, that a valid argument could be made that the Earth was stationary and the heavens were rotating above us at 15 degrees per hour. Shall we all say it together? 1, 2, 3. Thanks, Bob.
thanks, Bob.
Thanks, Bob.
All right. So, could the celestial sphere over our Earth be rotating at 15 degrees per hour?
It could. You just need more measurements to confirm that one way or the other.
Okay. Could we determine whether or not it was the Earth rotating, the celestial sphere rotating, or both rotating to contribute to that 15 degrees per hour? How would we look at that?
Stars.
Okay, well, the stars tell us that there's a 15 degree per hour rotation. How would we determine what part of that 15 degrees was due to movement of the stars versus movement of the Earth?
Well,
Oh.
I
My
would
ring
think
laser
that-
gyro bolted
Okay.
to a concrete pad.
A ring laser gyro will definitely pick up a 15 degree per hour drift. 1, 2,
In 3 axis.
1,
Coco spin one.
2, 3. Thanks, Bob.
Thanks,
Thanks,
Bob.
Bob.
Okay, so the ring laser gyro determines that it's the surface of the Earth that is rotating at 15 degrees per hour, which encompasses, thank you, honey, which encompasses the entire 15 degrees per hour drift or rotation that we see when we look up at the stars. We can account for all of that strictly based on the rotation of the Earth as measured directly by a ring laser gyro. Is there anything else that will tell us that it's the Earth itself rotating?
Well, I would say
Coriolis.
satellites.
Coriolis is another good example. Coriolis only occurs on a rotating body in reference to a stationary frame of reference. So, and why is it that we need two reference frames? We've got a rotating one. That's really all we need. What do we use the stationary reference frame for? Just to tell the first one's rotating. If
Correct.
we didn't have anything to compare a rotation to, we wouldn't know something was rotating, would we?
No.
Okay, so we've got Coriolis. Now, perhaps some arguments could be made somehow that Coriolis was caused by something else, magnetism. Okay? That's extremely unlikely, but we haven't excluded it. Is there any way that we can exclude anything other than rotation as accounting for Coriolis?
You could actually mount a gyro to a equatorial mount, align it with the polar axis, and counteract it on its own.
Okay.
Yep.
The only now with
That's
an
actually a good
equatorial
idea.
mount that would work with a rotating celestial sphere without a rotating Earth. But if you combine that with the ring laser gyro, you show that it isn't the sphere that's rotating. It's the surface that the telescope's on. It's rotating. Now, another one I heard a little while ago I think is pretty good, and that is the gyro compass, the mechanical gyro compass. Now, how does that prove that it is the Earth rotating rather than the heavens?
It'll always point to the line up with the east-west direction of the rotation and give you heading no matter where you are on the Earth, whether it's on the north or the south hemisphere.
Yep. The way a mechanical gyro compass works is that it causes gyroscopic precession that is restricted in one axis. And as a result, the entire gyro compass will rotate to an area of minimal energy. Okay? That area of minimal energy is aligned with the north-south axis of rotation of the Earth. If it goes beyond that, it'll be forced back to it. That's why it doesn't matter if you start the gyro compass facing east, start it facing west, start it facing south. Any direction other than north will cause that gyro compass to progress until it aligns itself with the north-south axis of rotation pointing due north, and that is the geographic north. Now, there was an interesting one that came out not long ago, and that is Wolfie6020 had this out on his channel. He actually weighed a reference weight in Perth, Australia. I think it was a 500-gram reference weight. And then he put it on an airplane, and he flew it east, and he flew it west. And the weight changed from the 500 grams in both directions. It weighed less than 500 when it was flying from west to east, and it weighed more than 500 grams when it was flown from east to west. That's called the Utvos effect. Why on a stationary Earth would things weigh different depending on what direction you were doing it? You were moving them. Can anybody come up with a single valid argument as to why something would be consistently weighing less going east and weighing more going west?
No.
So the fact that that happens excludes a non-rotating Earth or a stationary Earth. The fact that the ring laser gyro measures a rotation of the Earth compared to the stars also excludes a rotating Earth. Okay.
You could also weigh something close to the equator and closer to the poles. They'll weigh different also as well.
Exactly.
To anybody that's watching the stream, I've just posted a link to join the stream in the chat, Discord link.
Thank you. You guys are welcome to come on in. We'll keep an eye on that green room for you. So yes,
join the green room.
So objects do weigh different amounts, even though it's the same mass and the same scale. Objects do weigh different amounts the further away they are or the closer they are to the equator of the Earth and the poles. How can that be accounted for on a stationary, non-rotating Earth? Is there any way that that can be done?
Could be density of the core of the mantle below it, like when gravity mapping.
Okay, so we could have increased density at the North Pole because of that, and as a result, things would weigh more, right? Milo's having a moment. Milo's having a beagle moment. Sorry about that, guys. He's teaching the pit bulls how to howl. Hang on just a second.
Woo. We actually cannot hear the dogs.
Nope.
I don't hear them either.
That's because I just yelled at Milo, who was he's my beagle. He likes to howl at irregular intervals, and then he gets the girls who are pit bulls howling as well. I didn't know pit bulls could howl. All right, so
Form the dog.
under your idea that maybe there was increased density of the Earth underneath, causing this increased weight, that would mean that there would be increased density under the North Pole because things weigh more at the North Pole, right?
Correct.
But that would require mass to have some effect on how much something weighs.
Correct.
Good, because it does. We've proven it. As a matter of fact, Blue Marble is doing it right now. If he's still running here in a few minutes, we may run over and have a look at his Cavendish experiment. I didn't realize he was streaming at the same time I started to. But wait a minute, there's a problem with that.
All the gravity maps used by the petroleum industry also prove it.
Yeah, but there's a little problem with that, and that is that things weigh more at the South Pole too.
Yeah, it'd have to be more dense there also.
So how would that work? Why would there be selective density only at the North Pole and then, I guess, the ice ring? I mean, the Earth is much denser than ice.
Yeah, it'd have to be in the core, in the mantle, but you could, or on the crust. I mean, but you could drill and test the density.
All right. But
Or you
remember,
could use
we've only
acoustics.
drilled down about 8 miles, and then the drills don't work anymore.
So you could determine that how deep the density gradient is, but you could do it acoustically also.
All right. So we've got two things related to weight that support the idea that the Earth is not stationary. All right. We have the Utvos effect, and then we have weight differentials based on latitude. Is there any reason on a flat and stationary Earth that a Foucault pendulum should progress at the same rate day in and day out? How would a Foucault pendulum work on a stationary Earth?
Back and forth.
It'd just go back and forth, wouldn't it?
Yeah.
Yeah.
Why does it rotate?
In one line of travel, it would never change.
Yeah, I mean, but what would cause it to rotate on a flat and stationary Earth? We know that it would precess like that on a rotating Earth, but on a flat and stationary Earth, what would possibly cause it to precess like that?
The heavenly energies.
Heavenly energy. So we have to make up a term to describe that then. But we make up terms in science all the time. We have a made up term called space-time, right? You can't give me a cup of space-time and measure its density, can you?
No.
Well, isn't there space time in the cup?
Yeah, but how would you measure it?
How big is the cup?
So it's a made-up term. It's a term that we use to try and describe a model that we understand and can be used to predict things. And space-time is a pretty good way. That model seems to work. I mean, it predicted the bending of light due to the mass of the sun in Eddington's 1919 solar eclipse experiment, didn't it?
Yes, it did.
All right. We recently detected gravitrons, which are predicted by space-time. And, okay, have we ever made up stuff like that before? Did we make up another term once called luminiferous ether?
Absolutely.
Did we use that to try and describe things that we observed in nature? Yeah, we did.
Yep.
And we postulated things. We made predictions based on it. For example, the travel of light would be changed based on where we were in the rotation in the orbit of the Earth. So we can test these predictions. The problem that we ran into is when we tested luminiferous ether, it failed the test. The results weren't what we had predicted. Yet when we
the
test
results were negative.
Yeah, and when we test space-time, we actually do get results that mesh with what we predicted. And that's why instead of looking at luminiferous ether right now, we look at the concept of space-time because it allows us predictability. Now, any movement due to centrifugal force would not be possible on a non-rotating stationary Earth, would it? Yet we can measure the effect of centrifugal force with something as simple as a 500-gram mass and a precision scale on an airplane. We can measure it using the same equipment by simply changing latitudes. So these are testable things. I don't know, there was something here that I thought was kind of cool. And that was this video right here. Let me go ahead and bring this up for a second because I thought it might be fun to kind of have a quick look at it. Let's do two things. First of all, let's add me right there. And that way there I can say I modified this somehow. And we can use it for common or fair use. And then I'm going to take this video right here. Let's bring this up here real quick. These are actual images from the Juno spacecraft as it slingshotted around the Earth to go on to Jupiter. It actually looked at the Earth, and let's go ahead and have a look, and there's the date and everything. Now the interesting thing is when you look at the Earth and the Moon, a couple of things jump out at you. First, if you look carefully, that Earth is rotating, and you can see the rotations. And the Moon is orbiting around the Earth. But now look, you're starting to see obvious rotation on the surface of the Earth.
Yeah.
So the Juno spacecraft is essentially a non-rotating frame of reference. And what we're doing is we're using that to assess two other bodies, and we see movement. So the Moon is orbiting around the Earth. And the Earth itself is physically and visually observed to be rotating.
Bob,
Well,
check the chat.
That actually kind of looks like
like
it actually kind of looks spherical to me too, doesn't it? It doesn't seem to change shape as it rotates. Isn't that interesting?
CGI.
CDV Gaming. I invite you to come on and explain your theory politely.
Well, actually, nah, not right yet. Let me go ahead and change one thing here real quick. I'm going to move that over a little. Come on.
We also have at the moment, thankfully, sunspots on the sun, which obviously prove that the sun is a spherical body as well.
Well, as is Jupiter, and as is every other object in the known solar system, that's over a certain size. But I've got another thing here that I thought you might like. Here is that's not what I was looking for. I had another one of the same thing. Give me just a second here. I'm going to go pull it up real fast. Here it is. That's the one I want. My apologies for taking just a second. Now here's a higher resolution of the same thing and normalized for size. Let's go ahead and have a look at that. This is by Galileo, and this was actually done a number of years earlier. Well, a couple of things there. It's the same shape, even though you can obviously see it's rotating because there's Australia right there, and you see it moving from left to right. And the only shape that would maintain that circular shape, even though it was rotating, is a sphere. You can also see, well, here's Australia, obviously, and here's Antarctica. It's pretty cool. So we can visually see it rotating. But in any event, we'll go ahead and close that down. So how are we doing on rotation so far, gents?
Beautifully.
All right.
I
Now
don't know,
let's take a quick vote in the chat and in the YouTube chat. Do you think a flat earther can come onto our panel and somehow interrupt us disproving that the earth is flat and stationary? All right, because if I do allow a flat earther on the panel, the only thing they're allowed to talk about is providing a flat earth explanation for the Utvos effect, for Coriolis, for the differences in weights based on latitude on a flat and stationary Earth. If he can come in and give an actual explanation as to why objects weigh differently based on the latitude on the Earth, I'm all ears. Now, if you guys want to let him in, go ahead and say so in the chat. If you don't think that he's going to restrict himself to those specific subjects, proving a flat Earth explanation for weight differential, for example. All right, I'm not going to let him in. So I'm going to leave that up to you guys. If not, what we may do is we may let him in to a special room that we have just for flat earthers. Flat earthers can enter this channel right here, and we'll perhaps come down and visit him in the Fleur Funhouse. And if everybody's game for it, we'll go down and maybe debate him there. But this is just for serious discussion up here.
We'll
All
say a 1 in the chat for let him in, and a 2 in the chat for not letting him in.
Because everybody
It's up
seems
to
to
you
be
guys.
pretty comfortable
YouTube.
saying no. But you can use the 1 for let him in, 2 for don't let him in, if that's a little easier for you. All right, so
I'm okay with it.
well, maybe when we're done. So we've already looked at a number of things that have shown that the Earth cannot be stationary. Just physically can't happen. Because there are certain things that we would see with a stationary Earth, and there are certain things that we do actually see that cannot be explained by a stationary Earth. The Utvos, Coriolis, the weight differentials, the Foucault's pendulum, the laser ring gyro, the equatorial telescope mount, the mechanical gyroscope. These are all things that cannot be explained on a stationary Earth. So now let's go ahead and have a look at the other one. Is it flat? Now, how are some ways that we can tell something is flat versus not flat? We talked about triangles the other day. What do flight paths that are in large triangles on Earth do? What do the internal angles look like on those?
They add up to more than 180 degrees. It's called spherical excess.
Spherical excess. Is it physically possible on a flat surface for a triangle to have more than 180 degrees of internal angles?
Absolutely not.
Okay. Is there any way that that can happen? I mean, it wouldn't even be a triangle anymore. So the fact that flight paths between three cities at least 1,000 kilometers apart, if you look at those internal angles, they come up to more than 180 degrees. As a matter of fact, I think I did some calculations. If you look at a flight path from New York to Los Angeles to Anchorage, Alaska, back down to New York, each of those legs is more than 1,000 kilometers. And if you add up the internal angles of those three angles, you come up to 192 degrees. That's just simply not possible on a flat plane. What else is impossible on a flat plane that we actually see on Earth?
Sunsets.
Yeah, sunsets. Okay. With the sun going
Actually,
below
gravity.
the horizon. Yeah, but the sun going below the horizon, lighting up high clouds red and leaving lower clouds in darkness, or casting shadows upward, the famous upward shadow from Mount Rainier. These cannot happen on a flat Earth because the sun would have to be below the surface of the Earth to do it. Right? Is there any way on a flat Earth that that can possibly happen? You know, there's a thing called albedo, where you get kind of a glow from the surface of an object that can cast light upwards. But does that cause, shadows as well as direct sunlight does? Will that cause objects? There was a great image that I saw once, and I'm going to go see if I can find that.
The lunar eclipse is an impossibility on a flat Earth as well.
All right. Well, you can't have a lunar and a solar eclipse on a flat Earth. You're absolutely correct. But here's an interesting thing that proves that the sun is going below the horizon. Let me bring this up and show it to you. There we go. That's what I wanted, right there. Have a look at this image right here. I'm going to have to save it real quick and then open it. I know what I can do. Here we go. Now this is a very interesting picture, and you can learn a lot from this picture on the direction of the sun. I mean, to a trained eye, this is unquestionable. Now, notice that the top of this cloud and the top of that cloud is dark. The mountain itself is dark. There is some red underneath this cloud, indicating that there is red light coming from below. Yet this cloud shades the cloud above it, yet the underside of that cloud is even more strongly lit up in red. How is that going to happen unless the level of the sun is below this cloud? Is there any way that that's possible? Because on a flat Earth, the sun supposedly is above the level of the surface. It's above eye level. So, is there any way, due to perspective, that we can get the sun that starts off above us go below us?
Not that I can see.
Well, okay, so this clearly indicates and unquestionably indicates that the sun is below the level of this cloud. Yet a couple hours earlier, assuming that this is sunset, a couple of hours earlier, the sun would have been above this cloud. So if the sun was above the cloud, is there any way, according to perspective, it will ever appear to be below the cloud? That's just not how perspective works.
Impossible.
It's absolutely impossible.
Not. It just makes absolutely no sense for it to make that kind of a shift if you're talking a flat disk.
No.
In any way, shape, or form.
Does it work on other shapes?
Spheres. What do you think, Rodrigo and Squeak?
I mean, it would work on a curved surface very nicely, but is there any way we could make that happen on a flat Earth surface? Because
you'd have to drill a hole in the ground and bury it.
All right.
There's no way, and that reminds me of the pictures of the rocket launches where at night, where once the rocket gets high into the sky, then the sun starts to illuminate it.
Yes. Red's
Same
Rhetoric
thing.
had a really nice shot of that where the rocket went up in the pre-dawn hours and, you know, it flew and it flew and it flew, and then all of a sudden the sunlight started hitting the rocket trail and it was well above the Earth. I mean, it was in darkness on the Earth, on the surface. But when it got high enough, it actually flew into the dawn. Utterly amazing. So, what else is impossible on a flat Earth?
Circular
rocket flying into
star
the dawn
trail.
would be proof of the sphere.
Yeah, it is proof of the sphere. The fact that the
Circular-
ISS flies over, and you know, and especially if it's near sunset or sunrise, as it starts to fly across the horizon, you see it as a large, rapidly moving light in the sky. But then it'll reach a certain point above the opposite horizon where suddenly it blinks out as it goes into the shadow of the Earth. That indicates very clearly that the sun is below the horizon. That cannot occur on a flat Earth because if the sun was below the horizon, it would be burrowing into the ground. So what else do we have that absolutely excludes the idea of a flat Earth that cannot be done on a flat and stationary Earth?
Circular star trail.
Well, you also have the
I think Hunter tried to get something across here.
Yeah, the
multiple times.
circular star trails. Now you would get on a flat Earth with the stars rotating about the North Star. You would get
They would be
circular.
oval.
Yeah, you would
No,
get
that-
circular star trails
Only at the North Pole.
as you
Anywhere
look
else it would
towards
be
the
oval.
north.
Only at the North Pole they'll be circular. Any distance from the North Pole they'll be oval.
Yeah, elliptical. You're correct. They would be elliptical. The other thing is, as you look south towards the horizon, what direction would the stars be moving? Parallel to the ground, wouldn't they?
Yes, on
Yeah.
a flat Earth.
Okay, we don't see that. That again argues the fact that the Earth is simply not flat.
they also have the difference of appearance of the moon in the northern versus the southern hemisphere.
Yeah,
Yeah, the moon is upside down on the other.
Yeah, on a
hemisphere.
flat Earth, the moon would look the same everywhere because everyone's looking up at the moon from the same angle.
well, more importantly,
everybody would see a different phase of the moon from every direction.
You'd see a different phase, and what would be, say, a full moon in the southern hemisphere would not be a full moon in the northern hemisphere. It could technically be a new moon depending on where it was. All right. So there would be different phases, and more importantly, you would also see different surfaces on the Earth. You wouldn't see the exact same surface everywhere. If you were looking at it from the side, you'd see half of the surface that somebody directly underneath it would see. And then you'd see half of the top half of the moon would be the surface that the person underneath it couldn't see. And we've already seen that the moon is a spherical object because we watched it rotate about the Earth, orbit.
Yes.
What else would be an interesting thing that would just simply exclude the idea of the Earth being flat? Well,
the videos we just saw?
Yeah, the fact that we've actually seen it, and we know it's not flat because, we've seen it.
Yeah, that would do it.
Well,
hey Bob, is there a place that I can post a couple of pictures? I've just been rebuilding my 14-inch telescope.
BC context.
Yeah, just go right up there. We're in the middle of a live stream right now. Now, where was I with that?
We have pictures.
On a flat Earth, would the sun be in a different position or a different altitude above the Earth, simply depending on where you're observing it? So, for example, if Bjorn in Norway and me in Michigan and Rodrigo in Brazil were looking at the sun, would those suns that we see not only be in different positions above the, different altitudes, different absolute altitudes above the ground? Could we have 3 suns simultaneously?
Having more than one sun would be impossible. That just cannot happen.
Well, the thing about it is if you have one sun and I have another, how come I can't see yours?
Well, I would think that you would see no matter where you were, you would see a light spot in the sky if the Earth was flat.
Right.
But we could triangulate how high that light was above the ground.
Yep.
And we could also determine exactly what piece of ground that sun was directly over, because it would be at 90 degrees above our head. So if it's 90 degrees above my head and Bjorn looks at it and it's 30 degrees above the horizon in Norway, we could actually calculate how high it was above my head. That's basic trigonometry. We all learned in like the 8th or 9th grade.
Basic trigonometry.
Well, we all know, but we understand the concept that if the shadow from a flagpole is at 45 degrees and we want to know how high the flagpole is, all we have to do is measure the distance from the spot where the shadow is to the base of the flagpole. And that's the same thing as the height of the flagpole. So, it's not theoretical calculus is the point. It's a basic level math function that we all learned in middle school. We understand the basics of triangulation, and we also understand, those of us that were in the military, we use something called land navigation. And one of the things that you do is you look at a radio tower here and you look at a hilltop there, you identify those points on the map, and you shoot an angle to each of them. And where those 2 lines intersect is where you're standing. I mean, that's basic triangulation for something as simple as land navigation. But if we measured the length of a shadow and we knew where the sun was, we could tell how high the sun was. And on a flat plane, even though the angles would be different, the distance to the point on Earth where the sun was directly overhead would be different too. And we could come up with a consistent altitude of the sun, couldn't we?
Yep.
I mean, that's
I would think
triangulation.
so, yes.
But we don't see that on Earth, do we?
Nope.
And if we had a fixed elevation of the North Star, for example, we could predict what, by measuring the distance from the North Pole to where we were, we could predict what that angle would be if the Earth was on a flat plane. Yet when we do that, the angles don't match to what we actually observe. So that also excludes the fact that the Earth could possibly be flat. Would you be able to see the North Star south of the equator on a flat Earth? I mean, how far away from the North Star do you have to be before the height of the North Star equals 0 degrees? Let's look at another thing that they like to talk about a lot, and that would be, you guys all hear of the Black Swan? Where we saw, you know, they put a camera 1 foot above the water and saw some oil rigs 10 miles away. Neglecting,
Yep.
of course, to mention the fact the bottom of some of those oil rigs were kind of low, and it only happened on certain days of the year. Normally you couldn't see the bottoms at all. But their big argument is that would mean the radius of the Earth would have to be 265,000 miles. All right. What's the radius of the surface of a flat plane?
A flat plane wouldn't have a radius.
Well, technically, I guess it could. What if the radius was infinite? Would that would be
It'd
a
be
pretty
zero.
fun thing?
It'd be just, yeah, infinity. Whatever.
The infamous infinity, yes. So, if you come up with any value consistently of the radius of the Earth that's not infinity, the Earth isn't flat. We can come up with a value for the radius of the Earth by looking at shadows cast by the noon sun. We can come up with a radius of the Earth by looking at the dip angle from an elevation down to the horizon. We can look at objects that are past the horizon and see how much of them are visible and how much of them are hidden. And we can measure distance, the shortest distance between 2 points on Earth, very accurately. We can measure that distance. All of those can yield a radius of the Earth. And surprisingly, all those different methods of finding the radius of the Earth essentially come back to the same number when you have a statistically large enough sample. So the Earth has a non-infinity radius. Therefore, it cannot be flat. Could be bigger than we think it is, but it's still going to be a sphere. I don't care if the radius is 265,000 miles. It's still a sphere. All right? It's still not flat. What would cause a sharp horizon on a flat Earth? Where the land meets the land or the sea meets the sky. What would cause a sharp horizon on a flat Earth?
Magic sky fairies?
Magic sky theories. Yeah, that's a good idea. Can particulate matter and water vapor and such in the atmosphere result in a sharp horizon, especially one that's curved?
I don't know, Bob. Tell us.
What happens when we get a lot of water vapor in the air to the point it obstructs the horizon? Can you see a horizon? Can you see a horizon in fog?
I was going to say fog.
Yeah, that's called fog. You can't see the horizon. That's why we fly on instruments once in a while, because we can't see where the horizon is. We need instruments
Sometimes you
to
can't-
tell us where it is.
Sometimes you can't see 10 feet in front of you.
Yeah. They have a phenomenon in Fairbanks, Alaska that's kind of interesting. It's called ice fog. Fairbanks sits down in a valley of the Chetna Mountains. And one of the things that you run into is every furnace, every jet engine, whatever, puts out pollution. And then that pollution freezes in 60-degree or 50-degree below zero weather. And as a result, you get this thing called ice fog. And I have driven in that stuff that it was so thick you could not see the hood ornament on your car, much less the, and you couldn't even see the brake lights of the car ahead of you. So when they put on the brakes, you had to go very slowly, because when you put on the brakes, you didn't see that those brake lights were on until you almost hit them. It's kind of an interesting way to drive. I would not recommend it.
No, I would. I have experience with that, but not with the ice fog, but with heavy rain.
Mm-hmm.
Same thing where you cannot, you have to just pull off to the side of the road because, if a car stopped in front of you, you won't see him until the very last second.
All right. Well, if the Earth was a flat plane that wasn't rotating, we've already established, that it can't be not rotating. We don't see any evidence, so obviously the Earth itself does have rotation to it. Now, if it was rotating like a record turntable, we'd all be leaning south, wouldn't we, because of centrifugal force? And it wouldn't matter whether we flew east or west as far as weight. It might make some difference if we flew north and south, but it really wouldn't make that much of a difference. Actually, maybe that's not right. No, I think it might actually make a difference if we flew east and west. But the one thing that we don't see on our observations is everybody leaning south in a centrifugal force acting in a southerly direction in both the northern and the southern hemisphere.
Yeah, well, you wouldn't have
That is
any
true.
gravity
Don't.
on a flat plane like that.
Well, you really couldn't.
No.
Well, why couldn't you have gravity on a flat point? What would happen if we had gravity?
Well, any mass would be underneath you. And
Yeah.
if you're spinning, that wouldn't really help you from spinning off to the side.
Not only that, the mass would be evenly distributed. There would be no central point
Yeah.
that would be pulling you down.
Yeah.
There wouldn't be any down.
There wouldn't be any down. The other problem too is that if gravity actually existed as the way we understand it and can test for it, if
It'd
the
be
Earth
collapsed.
was of sufficient size, it would be required to collapse into a sphere.
Yeah.
Is there
Yes.
any force of nature that could keep a disk intact if that disk was the size of the Earth?
No. Well, other than gravity, no.
Gravity couldn't do it. Gravity forced it
No.
into a ball.
Yeah, exactly. But there is no other force.
No, there's no other force that would do that.
I wonder if
Especially
it
not
was
if it was
rotating
spinning.
fast enough. If it was rotating fast enough, maybe the centrifugal force would counteract gravity and keep it out. Like satellites orbiting Earth. If it's turning,
Or a ring
fast,
of Saturn, for example.
you just have to be turning fast enough to do it, and we're going to notice that because that would be
Very
What?
fast.
much
Very,
greater
very
speed
fast.
than we got now.
Yeah, definitely.
But
Definitely.
what?
And we'd see the stars moving by. We'd actually
Yeah.
see stars rotating at a different rate. We already know the rotational speed of the Earth.
Yeah, it'd be a couple RPM,
Yeah, it would.
at least 2 RPM.
Now here's another interesting question. If we start off, if the three of us, you Bjorn and I take off from the North Pole and we all head south in 3 different directions, which is kind of an interesting thing. We're going in 3 different directions to go to the same direction. We would end up looking in different directions, wouldn't we? Why would we see the same stars?
We wouldn't.
Again,
Impossible to see the same
Im-
stars on a pizza.
Not possible on a flat Earth.
Yeah, on a space pizza. That's impossible.
Yeah, it's just not possible. Anybody else have any good ways to prove that the Earth itself cannot be flat?
I'm just coming back to the pictures, the videos, like.
Oh yeah, you mean the old? We have an actual picture of it, and we know it's not flat because we can see it.
Yeah,
That argument.
It helps. It helps.
The original blue marble, of course, no CGI in those days.
Well, you could process images, but it was a completely different process, and you're not going to be layering on things and creating shapes that don't exist. Yeah, I mean it's absurd to do that.
It was called a dark room.
Yeah, it was called a dark room, and it took an awful lot of skill to do something that even you could you could do some things with pictures. You could accentuate colors and things like that. You could even superimpose one image on top of the other. But
just imagine,
how would you process a picture like the blue marble if it didn't actually look like that? And yet every single picture that we've ever seen looks like that.
Right. Just imagine how many Bendix G15s it would take to process that image of that resolution back in 1965.
Well, yeah, the blue marble. Yeah, that's the other thing is I actually watched Apollo 17 go up, so I know they were there. I knew they had a rocket up there. Couldn't tell you for sure if anybody was in it, but I do know they sent the rocket up. And we saw pictures that were taken by people that claimed to have been in the rocket.
There's a point I just tried to make since you started this, because what we said is that we can only disprove things, and that's totally true. Science can't prove something to 100%, but it comes to a point when it's so ridiculous. That's basically Russell's teapot. It's so ridiculous to say it's not true. It just as well could be true, or is true. We are come to a point where there is no point debating it anymore.
Well, someday, one of our children or grandchildren or even great-grandchildren may come up with something that explains the universe better than Einstein does. They might. I can't rule that out as a possibility.
No, but that is a big problem, a very complex problem. This isn't a big, complex problem. We have pictures of it. We send people out to space, and we can see it. We can measure it from the Earth. There's so many lines of evidence that converge on the same spot that to say that the shape of the Earth is one day going to be disproved is, nah.
I think we have it nailed, Bob, to 99.99999999999%.
Well, I think that we proved that it can't be flat. I mean, that's called the preponderance of evidence. We have proven that we have excluded the possibility that it could be flat. There are just too many things that argue against it, that are inconsistent with a flat Earth, that are inconsistent with a non-rotating Earth or a motionless Earth.
Not to get legal on you, but a preponderance of the evidence means like the teeniest little bit to tip it from one side to the other.
At least as likely as not.
We've proven it beyond a reasonable doubt.
Which means that no reasonable person could do it, and that is the stronger evidence, of course.
But technically, with better and better measurements, it was proven that it's not spherical; it's an oblate spheroid. So that's where the additions of increasing accuracies and measurements come in.
Well, in all honesty, we didn't start out to prove what shape it was. We started out to prove what shape it's not, and we conclusively proved that the Earth is not flat and stationary.
Yeah, and as for the oblate spheroid, you're talking a couple pixels out of round over the entire picture. It's only out a couple pixels.
So technically, it's not a sphere; it's an oblate spheroid. Yeah. But that only came into account whenever the measurements got accurate enough. Mm-hmm. So as you progress, the scientific census actually molds itself to what.
Yeah. You want to see an oblate spheroid? Look at Jupiter. That's an oblate spheroid. That thing bulges in the middle noticeably. Yeah. You can see it.
I have a video that demonstrates the oblateness of Jupiter. from pictures I took through my telescope. It's blatantly obvious.
Well,
Well, I hate to tell you, Bob, but I must be an oblate spheroid too because they bulge in the middle a little bit.
no, that's just boomer. That's boomerism.
But my point wasn't that my point is that don't give the flat earthers the argument that we can't prove something to 100% degree, because even if it's true that we can't do it, we're starting to talk about you might be delusional, everyone might be delusional, you might be a brain in a jar, these kind of arguments.
Hey, John, you around? We're honored by one of my friends from the Aussie chat, and that's John Watson.
Well, there is a brain in the jar. I think it's called Dead Kennedy in Space.
Yeah. All right.
Oh, fuck.
Well, flat earthers, here's your chance. I'm going to go ahead and invite the flat earthers to come in and chat. So,
Please, not Nathan Thompson.
No Nathan Thompson's allowed.
all right. Flat earthers, when you come in by using that link, go right here into Flat Earthers, enter here. We'll bring you down here and we'll come join you, and then I will broadcast that and you can make your case. Is there anyone that will step forth and try and explain how any of these things occur on a flat and stationary Earth?
I don't think you're going to get any takers, Bob. Well, maybe. I'd be shocked.
Well, we'll give them a moment. Right there. Right there.
The
That's where
gambler?
you come.
He's not a flat earther.
Oh,
Gambler's
okay.
not a flat
Hello,
earther.
Gambler.
Hello. How's everyone
Yeah.
doing tonight?
How you
Not
doing?
bad.
We're discussing how to prove the Earth is in fact round and not flat.
Well,
No.
no.
I'll listen in.
What we're discussing is how to prove the Earth is not flat and stationary. That's all we're addressing. So we've essentially excluded the possibility that the Earth is flat and stationary.
It's a live stream on YouTube, Gambler.
Yep.
I understand.
Yeah.
So we're simply just reverting back to the days of Copernicus and Galileo in a modern setting.
Yes.
Yes.
I'll be listening in then.
All right.
Don't mind my output.
Let's
I
go
think
ahead and
we're-
have a look at one thing here real quick. Here's another interesting question for the flat Earth. Dum 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 dum. What's that the theme song from? Anybody know? Dum 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 dum.
Oh, that's
Two guys on a train.
Wild Wild West.
Yep. Favorite
Yeah,
song in my favorite show in 1972.
You have to be old to know that, Bob.
We are.
That was a great show. I agree.
That was freaking awesome.
I loved it.
It was
movie
very
sucked.
steampunk in a way, you know?
Yeah, the movie sucked, but the TV show was great.
Oh. Look at that right there. That is Venus. Now, to a thinking person and a trained eye, let me point out a couple of things here, and then we're going to see whether or not we can make some deductive reasoning and figure this out. Notice on the crescent Venus, it's far less than half illuminated, okay? It's also considerably larger than a full Venus. And notice too that you start getting to about a half Venus right here, and then it just gets smaller and smaller and continues to get larger and larger. Here's the question for everybody. Does this mean that Venus is between us and the sun, or were between the Sun and Venus? Now let me give you a slightly different one.
I'd say we're between the Sun and Venus.
Well, you would be wrong.
Don't forget the retrograde motion of Mars.
Yep.
And we all have to be wrong once.
Yep. Well, it's okay.
Even you, Glass Monster.
Be careful saying we're between the Venus is between Earth and the Sun. I've get a lot of responses that if it's between the Earth and the Sun, we could only see it during the day. They don't seem to think that it could be on the side of the Sun. It has to be directly in between Earth and the Sun.
Yeah, the orbit of Venus is closer to the Sun than the orbit of Earth.
I do think we have a flat earther in here.
Oh, dear God. All right,
Very
here's one
flat.
right here. All right, now compare that image to this one. What's interesting about that? Now here's dates. March 19th, May 9th, June, July, October, December, January, end of January and March. Notice that the phase of Mars is never below 50%. It's off a little bit here, see? Just a little bit. But most of the time, it's pretty much a full or nearly full phase. That means that we're always looking away from the Sun. What we're looking at the side of Mars that is lit. And the only way that that can happen geometrically is if it's further away from the Sun than the Earth is. It orbits outside the orbit of the Earth, whereas Venus, which shows phases, as does Mercury, orbits closer to the Sun than the orbit of Earth. There is no time that we will ever see anything like that from Mars. We will never see the Sun eclipsed by Mars, or Mars pass directly between us and the Sun and appear as a black dot that goes across the disk, such as the transit of Venus. So, I mean, we've excluded the idea that we're in the center of the solar system. With that, we have two planets, at least, that are closer to the Sun than we are. But that's interesting stuff. Let's go see who we have up here. You said you had somebody waiting?
No, he's
There's
in the
one
flat-
sitting in the flat Earth.
Yeah.
Well,
Well,
there
he's
he
in-
is.
Got to put him into the fun house.
Well, let's bring him up here. Hi, Barry, and welcome.
And it's gone. And
No,
it's
he's
back.
Hello, Barry.
And no.
he's gone. There he's back.
Well,
Is
I
he
mean,
being
certainly
kicked
you
out from
have
this?
convictions of your belief, and you've got an explanation as to why we have the Utvos effect and weight differentials, for example, at different latitudes. I personally am waiting with bated breath to hear how he explains that on a flat and motionless Earth.
Maybe we need to put him in the fun house and go down there.
Yeah, he might be getting kicked out of Live Bob because he doesn't have the permission.
Well, hang
Because
on a
he
second.
has the flat Earth.
Barry, you there?
Yes, I am here.
Okay. Well, you want to have
Hold
a
on.
chat with
Let
some
me
folks?
get to my Discord real quick. I'm on another tab.
Bob,
Well, did you want to come in and offer an explanation?
I do not have an explanation for what you were just talking about. I do
Okay.
have my theory about the how the flat Earth could work if space is real.
Okay, does it specifically address anything that we talked about in the live stream?
Yes.
Okay.
It addresses the rotation of the stars and the fact of how the disk could actually be a flat disk and rotating still around the sun, but at an angular course.
Okay, so
If that makes
you're
sense.
going to offer a flat Earth explanation of star trails. Am I correct in that?
Star Trails was part of it, yes, but mainly of how we can have a different moon and sun, like the eclipses, mostly.
All right, gentlemen, let's give the floor to Barry and hear what he has to say. I'm going on mute.
Yep. Now, I just want to be clear. This is CDV Gaming on the live stream chat. I am not a flat earther, but this is my theory. Because I don't know if it's true or not. But if the Earth is a disk, or even has it could have some roundness to it, but not a sphere, but a flat disk, more if you think of, if you cut a bagel in half and take the top of the bagel, it's slightly rounded like that. And instead of sitting flat on the orbiting plane of the sun, it sits at an angle. I'm not talking 45 degrees, but I'm talking a slight angle facing towards the sun and rotates at whatever the RPMs that they want to say it is. I don't really care about that. 1 day cycles. And it's going around the sun. You could still have the moon rotating around it and have your eclipses. And the star trails I don't think will work. I will admit I'm not a scientist. I'm just an average guy who comes to Bob to learn stuff. But yeah, I was about to say I'm not like I said, I'm not trying to be one of these I know it all. I'm not the Swinggate guy.
All right. Well, first of all, and I think the panel would agree with me, is that, well, the Earth does slightly rotate, or what does slightly tilt in relationship to the rotational orbital plane,
Yeah, on our axis. I know that. Yeah. Yes.
Yeah, and that's why we have seasons, and there are going to be times that the Earth is tilted directly facing the sun. That would be the June solstice.
Yeah.
And
the longest day of the summer and the longest day of the winter.
You would see rotation about the sun. Of course, you wouldn't see it because the sun would be out. But the problem that you run into is on the opposite side of the Earth. The stars rotate clockwise about an antipodal point to the North Star, to the sun. Okay? So, that just, it wouldn't work. The star trail simply wouldn't work. You could, the flat Earth doesn't have any issue trying to explain the northern star trails, but they can't explain the southern
but they can't
ones.
explain. Yep,
Because
exactly.
They wouldn't even look like
and
that on a flat
that's
Earth.
Sorry, I don't want to interrupt, but that's one of the reasons I wanted to come on and kind of explain that, because it's something that I've thought of, but I wanted it to be debunked immediately, and you are the guy to do it.
Did we let you down? Did we let you down?
Oh, no, you did not let me down whatsoever.
Right.
I am happy. You guys, I'm going to continue watching the live chat. I'll get out of here now. You guys have a good one. I'm enjoying
the
it.
good news is you don't have to stay in the flat Earth room, because at least, look.
Yeah. I'm not a flat earther.
You can actually recognize evidence. Okay.
Woo! Yeah. All right. You guys have a good one, and I'm going to continue watching.
Well, thanks for coming by. So
Thank you for having me.
We're all down
Exactly.
here. We're all down here, and we're waiting for the flat earthers to come in.
Good community. That's why I follow the channel.
Well, thank you very much.
No problem. You have a good one, sir. And everybody else that I don't know.
You're welcome to hang out on both of our servers.
I'm here.
All right. Well, hang out
Well-
here. If you don't have anything to say, just mute your mic, and when you want to talk, just unmute the mic and wait for an opportunity to come forward. Any other
Just
flat
want to say,
earthers out
Bob,
there?
that was great. That was someone on the fence
Yep.
who was set straight.
The thing
Generally,
is
when
that-
people say they're on the fence, they're actually flat earthers. They've already fallen off the fence on the wrong side
Yeah.
of reality. But he came in not as a flat earther, but with a legitimate question and with an idea, and wanted to maybe talk about it for a second and see whether or not it would work.
Yeah.
It won't.
But the thing is that, you know, on a flat Earth, you can't make everything come together. You know, if you can't explain all of it like you can with the ball, you really have a problem. You really have to be able to explain everything that happens. Seasons, you know, the stars in the north and the south, you know, positioning on the sun. Like everything has to be explained, and that happens in the ball. If you have a ball, you can explain that perfectly.
Yeah, but the thing with any conspiracy theory is that the core belief is the most important thing. It's more important than facts. It's more important than evidence. It's more important than anything. So the belief that the Earth is flat supersedes everything. So when there is no evidence of a flat Earth, and everything points the other way, it doesn't matter. That core belief is the most important thing, and that's the antithesis of science.
It actually is. For those of you who don't know him, John Watson is on the Australian channel quite a bit. I've known him for, I don't know, 2 years, John? But he's a really good guy.
Yeah.
I hope he'll hang out with us a little bit more. He's a great guy to chat with. But, you know, the thing about it is it's not so much evidence supporting the globe Earth that we're looking at today. It's the fact that we have conclusively ruled out a flat stationary Earth. And that's the significant thing. And the problem that you run into with flat earthers is they don't accept evidence. And that's something that...
Oh, there's no point debunking them.
Yeah, I have difficulty with that, because if I show you a picture of a curved horizon and I ask you a simple question, do you see a curve there? They will say no.
Yeah.
It is measurably curved.
Same with religion. You can't see God, but you believe it.
Yeah. But you see, religion is different than science. Religion is faith-based. And they're two different animals. Science is data-based and measurement-based and deductive reasoning-based. These are all
Thing
things
is, they
that you
don't
don't
believe
apply
in
to
science.
faith. That's the point of being faith. You can't confirm it. We can confirm
The thing
things in
is,
science.
when they got sick, they go to the doctor and take a vaccine, but they don't believe in science. That's the problem. you
Yeah,
will
they
never.
don't believe in
you will
taxes until they
never.
get a check.
Unless you're talking about the anti-vaxxers.
Yeah. But anyway,
Yeah,
that's not really
anti-vaxxers.
what we're...
I think you talk about anti-vaccines is more productive maybe because it affect us all. You know, when people start not taking vaccines, they are making diseases more dangerous. It's much more dangerous than flat earthers.
Yeah, but the thing is that flat Earth is the tip of the iceberg. Typically,
I don't think so. I think fanaticism. I don't know. Fanaticism. I don't know if that word exists in English, but
No,
I think that's the main problem.
I firmly believe that that people that think that the Earth is flat also are anti-Semites, racists. It's the tip of the iceberg. If you believe the Earth is flat, you will believe anything kind of.
I think that sums it up right there, John. If you believe the Earth is flat, you're susceptible to believe anything, and that's why they're so vulnerable to these conspiracy theories. People that give them answers that they don't have, and we just conclusively proved that the Earth is not flat and motionless. Yet people will still do this. The first video I ever made was you don't have to dip the nose of an airplane to fly it around the curve of the Earth, and I, in 10 minutes, explained exactly why. I figured that would be the end of it. But they asked the same question again and again and again. How many times have we been out here? Brandon Toy is still trying to figure out how jetliners going from Anchorage to Mexico City keep up with the rotation of the Earth. He's still trying to figure that out. It's been explained to him multiple times. They don't want to hear it. They just keep asking the question as if somehow the answer is going to change. It's not.
So why don't we ask them what their model says? Because if you take two of their models and try to, put them together and see if they work together, I bet you they won't.
Well, the problem
There's no
is,
point.
as we saw today on 24/7, they're not looking to have a model, because if they had a model, they'd have to defend it. All they have is misdirection and misrepresentation, and they play little definition games. All right, that's all that they have. Their only strategy is to try and attack your model. And they do it very poorly and then claim victory. It's, as I said, it's pigeons playing chess.
Yeah, that was exactly what I was thinking. But I think it's more important to put them up in the corner and try to get them to make a model, because if they're just gonna say that your evidence is lies and such, there's nothing you can do. And stupid people will believe whatever they want to believe. So if they look at the video, they just gotta believe the person they find convincing.
Well, I used to have
y'all were on 24/7 server.
You might say that.
Oh, I was banned from that server.
Oh, I've been. My main account's been banned. They don't have them all though, so I can still.
I just think that debunking a flat earther is something like legitimizing them. I don't.
Yeah.
Kind of don't like
yeah.
it. And you could say, oh, but you have to expose them and stuff. Well, our president won an election because a lot of people make jokes about him, and he got media, and now he's president. So yeah, if you give a stage to this kind of people, they will grow.
Well, I
don't think so.
I used to do a couple of things when it came to debates. First, I used to actually debate flat earthers. I don't really do that anymore because it was just an exercise in frustration for me. It's like trying to talk to a wall and teach it how to do algebra. You just can't do it. Then I went to the...
Theoretically speaking, it would be easier to teach the wall how to do algebra.
I think you're probably right, because at least you can draw algebra on the wall.
Yeah, and the wall will listen. It won't argue with you.
Yeah, it won't argue with you. Exactly. Then the next thing that I did was I came up with 5 questions that a flat earther had to answer in order to debate me. And one of them was, okay, where does the water from the tides go? All right. If the atmosphere has a pressure gradient and that pressure gradient continues to go down as you go up, how high does it have to be before it stops going down at a non-zero amount? Okay, because little things like that. If I hold a pencil in my hand, if I drop the pencil, is the pencil at rest before a force acts upon it to cause it to move? Little questions
but see,
like
Bob,
that.
with those questions, like with the atmosphere question, the problem there is that you're already presupposing a sphere,
No, I'm
right?
not.
But
Yeah, but
yeah, okay,
that's the flat Earth claim.
Well, that's
okay.
fine. You still have to tell me at what height
your
the
your
pressure
questions
stops
are good,
going
but the
down.
thing is, your questions are good. The thing is you're speaking with crazy people. So what's the point of making
Yeah.
those questions? They will not even think about it. You know.
I know.
And
then
They will-
regarding the,
I've changed that
Go ahead.
though lately. I used to have the 5 questions. Now I do something a little bit different. And that is if you first, there is no debate on the shape of the earth. We already know what it is. If I debate you, it's humoring you. I am humoring you for my own amusement. And
my
to maybe
theory.
hang on
My
just a
theory
second.
is.
And
my
maybe just
theory
to
is-
teach something to the audience a little bit. Now, the next thing that I tell them, and this is very clear, I will present you with evidence. And if you do not acknowledge the fact that I have presented you with evidence that is right in front of you, for example, that line is curved. All right?
Yeah.
I will show you that it's curved. If you will not acknowledge the fact that it is curved, that objects drop to the ground when we release them. If you don't acknowledge these things, I'm done talking to you. And the discussion's over.
That's what I do
There
today.
were-
I end conversation when people start to when they make no sense at all. You know, there's no point in continuing the argument.
And there were some servers that was on in the past where they would have a debate channel, and one of the rules of that channel was it was fairly simple: counter or concede. And the whole idea of that was if someone put a point that was being argued, you either had to counter that point or you had to concede it. You couldn't, if you were caught trying to like deflect or jump subjects because you couldn't counter it, then you'd get
would count as
booted
concede.
over to the kiddie channel.
Yeah.
Yep.
Yeah. Well,
And I know it's been a while since. Go ahead.
Well, I was just saying that I have a theory that there's an amount of people that are just crazy. You know, they're just crazy. They they are fanatic for some stuff, and you can't do anything about it. So, as you guys were saying, there's no point. There's no point trying to convince them about anything. You know, you would have to make a new religion and about science, you know, or something like that, so they could eventually maybe be converted to your science religion. But there is no way out of religion for them, you know.
I don't buy that, Rodrigo, for many reasons. First and most importantly is that usually you inherit the ideas of your parents, and they're going to be hard to shake off over time. But when you get to a certain point, you see that more and more people actually do it when they go to college, when they do, you know, start reading their own newspaper and stuff. And I do think that a lot of these people are just living in an atmosphere where people believe this kind of stuff. And if you remove that atmosphere, if you remove them to a different place where they get to talk to other people, it's going to be harder and harder for them to keep those beliefs.
Well, but then how can you explain that when I was little kid, there was just a few people talking about the flat Earth here in Brazil, and now there's a lot.
Well, you know, when you were a kid, YouTube wasn't much of a
YouTube
thing.
wasn't a thing.
Yeah.
Hmm?
YouTube.
When you were a kid, YouTube was not a thing.
Yeah.
Yeah, internet was not a thing here.
Exactly.
So-
Now all the crazies can get together and talk to each other.
Oh yeah, so that's what I'm basically saying. Crazy people,
Yeah,
because
yeah,
they,
but
they will
man-
never they will never count that there is science proof things. They don't care about it. You know,
Well,
there's no
people
point
change-
trying to.
People like this change their mind all the time. And if we just give up and say, it's not worth it, the only thing that's going to be left on YouTube is people that say the Earth is flat.
Bjorn's right. I've come across quite a few people and I've had one-on-one conversations with people, and the being able to have a one-on-one, and they start off with the same rudeness and everything as most of the flat earthers, but the more you talk with them and get a rapport with them, it ends up turning into a decent conversation, and they actually get a little bit of information. And I think sometimes, there's been several times I'm convinced that I was able to get them to question things for themselves and actually think for themselves a little bit instead of just following what they hear on YouTube.
Yeah.
It's always important to have a resistance to any movement. If you just give up, you're never gonna change anyone's mind. And the first thing, the first thing you have to do is actually put out the real information on the interweb.
But when you create resistance, you create polarization, and it creates a lot of fanatic people.
Yeah, but you're gonna have that small group anyway. That's the hardcore.
Yeah, you kind of have to consider that there are people who just don't want to have their minds changed.
Yeah.
I mean, how do you argue with people who think space is fake and satellites are fake and nothing's real, even though they sit
sun
there?
Is hollow.
Well, they sit there and they'll sit there and they'll watch an NFL game today on the television, which is broadcast because of satellite technology, but it's all fake. But yet they're just watching it on television.
Yeah, I say that because
how do you deal with these people?
I say that because I have friends that are highly educated. They do science in their everyday life, like electronics or websites. You know, they do like things they do technology at least, and yet they don't believe in a lot of science. They believe the Earth is hollow, you know, some things like that. And there is no way you can show them evidence, and yet they will say that the Earth is hollow, and there is nothing you can do about it. You know, and they are educated. That's frustrating.
But I do believe that for everyone that you find that you can't change your mind, there is at least 5 you can change.
Oh, maybe,
because there's got to be a group of hardcore fanatics that you just can't do anything about.
Yeah, but keep in mind that I was talking about this group of people that will not change their minds, because I think they exist. You know, there is a group of people that will not change their minds.
Yeah, I just said that is true.
Yeah,
that's definitely the case. But I've had people come to my channel and try to tell me that the images in my telescope are fake and planted by NASA and all of this stuff. And so we have a conversation. We talk back and forth through comments and everything. And one guy in particular, he had it on his own telescope, but he's only looked at the moon. Well, I finally talked him into trying to take a picture of the Orion Nebula. He didn't think it was possible. He thought it was all NASA fakery. Until finally, after weeks and weeks of talking back and forth, he finally got a picture of Orion's Nebula, and he saw that it was real. It was something that he could take a picture of for himself. He didn't believe my pictures. He didn't believe anybody else's pictures. But once he took his own picture, it made it a lot harder for him to disbelieve.
You have to counter bad evidence with good evidence. That's the only way you can do anything, you know.
So earlier,
what happened? Sorry, IB Hunter. What happened?
We went back and forth for another couple of weeks, and then he he actually kind of disappeared on me. I haven't heard back from him, and he stopped posting anti-ISS, anti-NASA videos on his channel. And he kind of went dark. I actually haven't heard back from him. I've sent him a couple of messages. He was a real nice guy. And we actually, once we kind of got past that first initial, where he saw me as a threat, once we got past that and had a decent conversation, he ended up being a really nice guy. He just didn't understand, excuse me, a couple of things. And I usually recommend ways for them to test for themselves. And there's a ton of ways to do things for yourself that you don't have to rely on anybody else. And the fact that he had a telescope available, that was perfect. We could do something and we could work our way through it. He saw my channel. He saw Jupiter rotate. He saw Mars rotate. He saw all of the stuff that I've done to compare with Hubble, and he just thought it was all fake. But once I convinced him to do it himself, and I taught him how to do it, he just couldn't. He said, "Yeah, I got something," and it didn't come out good at first. And he tried a few more times, and he got it better. And then he kind of just quietened off. Now, did he convert? I have no idea, but he did start to question at that point. I think.
Teaching him how to do it, that's the big thing, because
good work, man.
Because you got people out there that, like, they'll try and do something, but then it comes up they had their camera out of focus and didn't realize it. They don't understand how important it is to have the object you're looking at in focus for the camera. So you end up with people claiming crazy things like, "Oh, look at this orb of light that's just dancing around like it's in water."
The problem he was having, his biggest issue was he would go and he pushed the button on his camera when he was trying to take the picture. Well, that vibrated the telescope. So I had to teach him how to use the timer setting on his camera. So he wasn't.
Yeah, where you hit the button and it waits 3 seconds or whatever before it takes the picture.
Exactly. And then he started getting results. Because he had tried it several times and he wasn't getting what NASA was getting. So NASA was lost. So once he was able to learn how to do it himself and why he had to do that timer thing, why that was important, then I think he started kind of questioning things a little bit.
Great work.
What about a remote switch for your camera?
I'm sorry, I didn't hear you.
What about a electronically controlled switch, a remote switch that you don't touch the camera, you just press a button on a remote device?
That would work.
He didn't have that.
Yeah, that does work better, but I don't have that.
I had to use with what he had. So.
Yeah. So I don't have that for my camera, so in absence of that, I use that delay setting. But what I wanted to say something earlier is I think at some point the whole bit about whether a plane has to dip its nose down every so often or whatever came up. I've tried going through that thought process with flat earthers on that 24/7 Discord server, where they will agree that yes, there is something keeping that plane on the ground, and planes are designed to counteract that something and get up into the air. But the disconnect is I'm sorry, my phone just went off. The disconnect there is after that point of it getting off the ground and into the air, they think at that point it no longer has to keep itself in the air until it tries to go back to the ground for some reason.
Shit. I don't get this this thing about the nose dipping down and the flat earthers being unable to understand it. The altitude of a plane when it's trimmed and you're at cruising altitude, it depends on air pressure. A plane will continue to fly at the same altitude because of air pressure. It's really simple. It's such a simple concept. And if flat earthers don't, well, I don't know, they don't understand it, or they refuse to understand it, that's nothing to do with the simple reality of how it works.
Well, the key to it is they don't want to understand it because it violates their narrative.
Yeah.
I'm probably gonna say it incorrectly, but like when it comes to a plane at cruising altitude, it's not that they're having to. Let's see. I'm trying to think of how to say it. So it's more that they're trying to keep a set speed and a set amount of lift to retain that altitude. Like if they were getting more lift than they needed, then yes, they would climb higher and higher and higher, and they would have to dip their nose down to get back to that altitude, but they're not doing that. They're just maintaining a set altitude.
They are fighting gravity.
That's the problem.
Yeah.
That's the problem, is they don't understand what altitude is. They think to follow the curve you have to decrease altitude, but you don't. You keep the same altitude because altitude has to do with the elevation over the ground.
Oh yeah, that's a famous thing, you know. Like, well, how, you know, it's 66,000 feet difference over this course. You know, where do you descend? You don't descend. The ground drops away from you, and you drop with it. Simple as that. You know, here's another question that I had. You know, another thing that totally debunks the idea of flat Earth. All right, we're familiar with what a meteor is. You see a shooting star in the sky. Okay. If that comes from Earth rather than space, what speeds it up to the point that it starts glowing? I mean, is there a force acting on the mass of the meteor to speed it up, to get it fast enough that it glows? You know, give me an answer on the flat Earth. If not, they're coming from somewhere else, and they're already going fast.
And here's the other thing about the whole plane having to dip its nose down argument from the flat earthers. It's like, okay, worst case scenario, the Earth is flat. That means that a plane would have to constantly be turning left or right to maintain a direction going west or east. I'm pretty sure we don't see a plane doing that either.
Well, that would be true, but at most latitudes, that degree of bank angle would be so minute you'd never notice it.
For those of you that don't recognize that syrupy voice, that is Blue Marble Science, my friend from Tennessee, who has he's a fellow creator, does some really strong work on the channel. Blue, let's get you a proper role here.
Does anyone know this guy that keeps jumping in and out of the server?
Yeah,
it's that Brian Peck guy.
Brian Peck? Yeah, we want Brian Peck in here.
Yeah, he
keeps joining and leaving.
Yeah, Brian's a good guy. He's a physician. He's the guy I did the Spanish flu series with.
He has a little bit of a problem staying in this room though.
He may be on his phone. He's probably working a shift right now. Yeah. You know, he's a frontline doc, and you know, if he can make it in, we'll let him in. If not, I'll apologize and kick him, and figure out a way to change his evil ways. But
the problem is when people jump in and out like that, audio is cut by from someone that's speaking.
Yeah. Hey,
And
Blue, if
also
you get a
Google Play.
chance, drop a link to your channel in the VC text, because Blue actually is building a Cavendish experiment right now, just as Cavendish did. He's got the thing in his garage. I mean, it's built like a piece of furniture, and it's just amazing. And he was doing a test tonight, apparently, on a live stream. How'd that work out for you, Blue?
Surprised me, to be honest with you, Bob. It was just a quick. I was just going to do a very quick test to see if I was up to speed on how to stream that stuff. And all of a sudden, there were 50 people watching. So,
yep.
I hope you
that's
didn't prove
amazing.
the Earth is flat.
By accident.
Oh, I don't think so.
Are we still
wasn't
on
wearing the
YouTube,
chicken
Bob? We
suit.
still streaming
Yeah,
on
we're
YouTube?
still on YouTube. I'm going to go ahead and probably shut her down here pretty quick. I'm looking
Was
at
there
some
49
of the stats.
Glovers and one Flurf watching that Cavendish test?
Say again.
Was it 49 Glovers and one Flurf watching your test? You said you had 50 watching.
Yeah, I think probably something like that. See any flirts in there? I'll be honest.
You know, Blue, you'd probably like this over here because this is kind of a flirt-free zone unless we invite them in. You know, we don't put up with the nonsense. I
do like that.
I had a weird experience today. I was over on Jose's with SE Montreal, and they were
Yeah.
talking about this silly video that he did about a bridge that was 13 miles away, something like that. You know, he's from a
Yep.
2-meter elevation plus whatever his camera was set at. And the bridge that he was talking about was like 159 feet high. Of course you can see it. But it was just such
Yeah.
a god-awful video. It was out of focus. It didn't concentrate on anything that allowed you to get landmarks. I had to watch
Well, you
it 4 or
can't-
5 times.
Yeah, you can't really make out that dam that's between
Yeah,
where
wonder
he
where
said
that
where
is.
he was. It's
Where was
there,
that?
but you can barely see it.
Yeah.
The contrast level is so poor.
And it was nothing but, you know, automatic focus and stuff like that. It was just a horrible thing. But here's the
Well,
interesting thing about it, and, you know, and I'll be the first to admit it. I analyzed that, and I found out that he had been accused of not being where he said he was. He was exactly where he said he was. It just didn't show anything. But he was where
Yeah.
he said he was. I
I
traced him
think he
back.
probably was. Yeah.
I traced him back, and I found him.
What I found interesting is the way the way Montreal so strenuously objected to Erebus, accusing him of being dishonest. When every day of the damn week, Montreal does exactly that to me or you or Janachik or somebody. Montreal is constantly, essentially calling us liars, but he gets all upset when somebody insinuates that he might be one.
Well, it's just like a flat earther talking about the Dunning-Kruger syndrome. You know,
Yeah.
I just, you know, it's just the irony is just dripping from that. I mean, it's almost
Yep.
amusing.
Absolutely.
Well, does anybody else have anything to add, or can we shut this bad boy down? We've been going for about an hour and a half. Thank you very much for the super chat, Judy. I do appreciate that. She's a great supporter of this channel, and I'll tell you, I appreciate it. Everything that goes to the Patreon, especially, goes directly into buying equipment and such for this channel to make better videos. And so if anybody wants to support the channel with a super chat or become a member or a Patreon, it would be very much appreciated and put to good use. And
Brian
take a
is in
moment
here
too
now.
and go sub to Blue Marble Science. He's a good guy. You will enjoy his videos. He and I both measured the circumference of the Earth in our first joint video back in March of 2019, right when he was starting his channel.
Yep.
It's round, by the way. Spoiler alert. It's
Round,
not flat.
round, the Earth is round. We all know that the Earth is round.
Well,
Thanks, Bob, the science guy.
Yep, you're welcome. It's just what we do, man.
Just want to say, Bob and Blue, keep on keeping on.
We'll keep on keeping on.
All right.
All right, YouTube audience, I wish you all a good night. You guys can stay here in Flurf chat if you want to troll for some Flurfs, or you can go back up to the 24-hour discussion and carry on your conversation in a Flurf-free zone. So this is Bob the Science Guy signing out from Northern Michigan. Keep safe out